For this particular one, I'd like you to actually draw all the E1 products that you would anticipate from this, all the readily observed E1 products that you would anticipate for this. So just take, like 60 seconds or so and draw the types of products that you think would happen if you were presented with this particular reaction. A little different than the last one. Last one we had a T-butyl group, here we don't. But just try and work your way through the sketch a little bit. If you don't have to use a mechanism, don't. It's a little time consuming right now. Try and think, where would the carbocation end up? Where are our beta hydrogen? If you can think that far ahead, you can easily predict two products for this reaction right away. So try and draw two products here that you would anticipate. I'm going to draw in some answers momentarily. What products would you anticipate? Okay, if you've done that or you're waiting, which is the major product, which is the minor product? Add that to it. So what two products would you anticipate for this? When I look at it really briefly, I know there's going to be a carbocation here at this alpha position eventually. I know I'm going to have a beta position here. I know, there's a hydrogen here. There's hydrogens here. So I have two beta positions. So even a little sketch like this would help me anyway. One of the products I could form would be this one. The other product I would form, or reasonably expect to form, would be this one. And I hope you guys will agree with me on this. If you have something different, talk about it right now with me, or if you missed one of these two, or really perplexed how I got here so fast, now is the time to talk about it. No need to be shy. You can always send me a private message. Some of you do. I get all these great messages. Public, private, all sorts of things, yeah. Well, maybe you're all zombies today, or maybe it's all perfectly self-evident what we're doing. So these two things are logical, natural, and obvious when we look at it as carefully. So these are ones that you should be able to predict on your own, no problem. And now what I want you to do is explain with mechanism this particular alkene. Give a detailed reaction mechanism that explains the formation of this alkene. I would say it's unexpected. These are expected. How do we get a double bond over here? Carbocation's here. So right now, take 30, 60, how much time do we need for this? We need about 90 seconds for this. I want you to give a detailed reaction mechanism that explains the formation of this. How about you actually start the whole process from this alcohol plus sulfuric acid. I want you to go all the way to carbocation. I want you to figure out how to do rearrangements, what you would do with this, and give the final steps to give the E1 to formation here. So this is about a 2-minute exercise or activity. You need to draw all the mechanistic steps. I want you to do it, get as far as you can on this on your own, because then I'm going to show you the answer. And if you just wait to see the answer, you're going to have a rough time when I ask you to do this in 2 days on your own. So you should be able to draw something, right? Even use your notes from today. Absolutely okay, but you should be drawing things right now, drawing something, okay? So have a crack at this. Detailed reaction mechanism starting from here, all steps that explain this otherwise unexpected product. While people are doing that, type comments, questions. Turn on your mics. Anything you want is okay with me. Good 2 minutes on this on your own, I think, is enough time. Maybe it takes about 5 minutes or so, but I can't sit here for 5-10 minutes and wait for everybody. So spend a minute or two on this. Get it going. Do an acid-base reaction you should have done by now. Water should have left for many of you by now, and you'll be staring at a carbocation. That carbocation you should look at very carefully. That carbocation should explain our first two expected products, no problem. Can that carbocation explain our unexpected product? I don't think so. So that's when we turn our rearrangement thinking on. Again, I'm just going to sit here and wait another minute or two for you. Not because I'm being particularly lazy, but just because it's important that you try something, see how far you get without me. So some of you are finishing up by now. Some of you are definitely still in the thick of things, working. That's fine. Please keep working ahead of me. Just keep working. Most of the beginning of what I'm going to do now here, you've figured out for sure without a problem. It's not where there's any challenge. We get to this particular carbocation. Easily, everyone should be here or should have made it here. And then you should start hunting for rearrangements. If we were to do an E1 reaction at beta 1 position, that would have explained this alkene. If we were going to do an E1 reaction at the beta 2 position, that would give us this alkene. We're trying to explain this alkene. This alkene is going to need a carbocation somewhere else. So what we can also do now is explain or explore carbocation rearrangements. I'm going to do it in writing at first. If we did a carbocation rearrangement at the beta position, we have hydrides. At the beta 1 position, we have 3 hydrides. If we move one of these hydrides at the beta 1 position, the result would be a primary carbocation, and we would reject this. The other possibility is at the beta 2 position. Beta 2 position is a little more confounding, so what we'll do here at the beta 2 position, we'll fully expand this beta 2 position. This is the beta 2 position from up above. Oh, I'm really out of space here. So I'll go through the whole discussion for this. Yep. Sorry, Jennifer, I'm going to go through the whole discussion from start to finish here. I missed this. So this is the carbocation everyone should have gotten to. And if we were going to explain these first two products, we could do an E1 reaction at beta 1. There's protons here. If we expand them, pluck one off with sulfate, we make this double bond. There's one proton right at beta 2. If we pulled off that with the E1 reaction, we start forming this double bond. But neither of those possibilities of elimination reaction explains this one. So when we have something unexplained, we'll use carbocation rearrangements for that. So let's explore the carbocation rearrangements we have for this particular species. At the beta 1 position, there's 3 hydrides there. We could just move one. So we could take a hydride from the beta 1 position. If we moved it to the secondary carbocation, we get a primary carbocation. That logically is not going to work energetically. The beta 2 position is a little bit more confounding. There's two different groups at the beta 2 position. We have a hydride and we have two methyl groups. These are the two groups we could move. In the last example, we moved a methyl group. We could move a methyl group here. If we move a methyl group from here to here, you might try that. Do we make a better carbocation? So here, this is what I want you to write into the comments. I want you to write, this is secondary carbocation. If I move a methyl group from here to here, what type of carbocation ends up at beta 2? Primary, secondary, or tertiary? I move this methyl group. In the previous example, when I moved there are three methyl groups I move when we get tertiary. But here I need you guys to fill in the chat. If we take this methyl group and move it, what type of carbocation we get? Yeah, so if we move the methyl group, we would just generate another secondary carbocation. So this is secondary. And if we move this methyl group, I'm just going to do a really quick sketch here, right? So take the methyl group, move it. We'd have a secondary carbocation here. And this secondary carbocation is not going to help us explain this. It's no better in energy. It's about equal in energy. These aren't what we're interested in exploring this semester. So what if we move this hydride instead? This is going to lead to a tertiary carbocation, as you could see. Carbocation wants electrons. We give it some. And then we redraw the new species, and we ask if it's better than where we started. So the hydride I moved is this red one. There already is a hydrogen here. There's already 3 hydrogens here. Now if we look at this carbocation, is there an easy way that we could explain the formation of this product? How do we explain the formation of this product from this tertiary carbocation? We have alpha, we have a hydrogen at beta 1, and we have hydrides at beta 2, or hydrogens at beta 2. Obviously, if we pull off this proton, we put a double bond in the middle, we'll make more of this product here. But if we take this proton from the beta 2 position, if we pluck off a proton here and the electrons start moving here, this would help us explain this one. At beta 2, if we did an E1 reaction, this would explain that product. Okay, so this is quite complex, but maybe for some of you this is becoming a little bit easier since we were working on a little bit last week. You had some time to digest it. Again, I know it's challenging. I know it's confusing at times, but we're only using these rearrangements to explain unexpected things, and we'll be only doing this sparingly. We're going to look at one or two more of these types of examples. We'll see how much we can get through in the last 10 minutes we have together. If we run out of time, so be it. If you have any questions about this, want me to go back and read